Here's our second kinematics problem, which is a little bit more complicated than the first, but either way. It says, you are traveling at 20 meters per second and are slowing down with an acceleration of -5 meters per second squared. Another person is traveling at 8 meters per second at constant velocity. There is initially 15 meters of distance between the two of you. At what time do the two of you meet? This is a very unsophisticated way of phrasing the question because originally I just had like a picture to work off of, but well, we always want to like draw a picture if we don't know where we're starting at. So let's say that this right here is you. Alright, now you are traveling at 20 meters per second with an acceleration of -5 meters per second. And then this is the other person, and they are traveling at 8 meters per second at constant velocity, which means that they do not have an acceleration. So acceleration is 0 meters per second. And then the distance between, just ignore the sounds in the background, but the distance between the two of you guys are 15 meters. So we want to like figure out like what we're given and like what we have to imply from this. And so we know that you have initial velocity of 20 meters per second, and then you also have an acceleration of -5 meters per second. And then they have initial velocity of 8 meters per second, and then an acceleration of 0 meters per second. So from this part of the problem, you can imply that you don't know x and you don't know t. So you have two unknowns. And then I'm assuming that you've taken algebra, so you know what to do when you have two unknowns, right? The x's are going to be equal to each other because this is at the time that the two of you guys meet. But if we look at our kinematics equation, and then at our third equation, which I will write differently in a second, it contains acceleration, initial velocity, time, and then displacement. So I'm going to write it this way. X equals x0 plus VOT plus 1/2 AT squared. X minus x naught is the change of x, which is displacement. But like, there's a reason why I broke this down because at this position x is 0, and at this position x equals 15. So that's saying that their initial position is going to be at 15, which is why we had to make the distinction here. Anyways, if we plug all of this in, we're going to get x equals 0 because our initial position is 0 plus 20t plus 1/2 -5t squared. And then for them, they're going to have x equals 15 because of this part, plus 8t plus 1/2 0t squared. And if we simplify that out, we get x equals 20t minus 2.5t squared, and x equals 15 plus 8t. And since this is at the same position, we can set those two equal to each other. So we get 20t minus 2.5t squared equals 15 plus 8t. Alright, so you're going to simplify this algebraically, and then you're going to solve for it algebraically, which I will skip because everybody should know how to do that. And then we're going to end up getting t equals 12 plus or minus square root of -6/5, which is imaginary. So if it's imaginary, then you and this person are never going to be at the same place. So you never meet. And then there are going to be questions where you do end up meeting and you're just going to follow the same process. And if you get like t is a positive number and the t equals a negative number, then it's going to be the positive number because technically you can't have negative time in the context of our physics classes. Anyways, that's going to be it for the simple kinematics problems.